Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, for today's lesson, lesson 3.2.4, we're going to continue what we were doing in the previous lesson. We're just going to be looking at a couple of problem situations and using equations to solve those problems. And actually, in this lesson, we're going to revisit some problems that we had worked on earlier in the year. So, in this section, you have solved many equations. Sometimes these equations were given to you, other times they came from specific situations. You have begun to solve equations without using algebra tiles. In this lesson, you will continue to focus on how to show your work, essentially solving problems symbolically, just using paper and pencil. Okay, so part 2 of John's giant redwood. You may recall that John's favorite tree was growing in the forest, and he had charted how tall the tree was 3 years after planting, then 1 year later, and then 1 year after that. And he noticed a trend in the number of feet that that tree was growing. So you may recall that it was growing 4 feet per year. And so we were able to identify how tall the tree would be in the 6th year, in the 7th year, and then we went backwards to the 2nd year, 1st year, and then the 0 year would have been the year that it was planted. So you should have this table in your notes. I even think we might have written a rule for this situation back when we originally worked with this problem. If you can't find that rule, that's fine. Let's go ahead and take a look at this now based on everything that you've learned. See if you can figure out what the rule is for this situation. Now, if you can go back and find it in your notes, great. You can just copy it down, okay? Then, in your rule, this is the part that's new. What part of our rule, I should actually rephrase that, what real world quantity does the X in our rule stand for? And what real world quantity in our rule does the Y stand for? I feel like I'm confusing this a little bit. Maybe I should just read the words, but no, I'm paraphrasing a little bit. What real world quantity does Y stand for within our rule? Okay, so go ahead and answer those questions. Then take a look at C and D. John wants to know how tall the tree will be when it's 20 years after planting. So you can now use the rule, plug this number in, and declare your answer. And for part D, the tallest tree in the world in Montgomery Woods State Reserve in California, the tallest tree is 367 feet high. John wants to know if his tree were to grow that high, how many years would it take for it to be that tall? Okay. So go ahead and answer questions A through D, and then we'll check the answers, and then we'll do part E together. I'll talk about it, how I would answer part E. Okay, so go ahead and pause, work through each one of these 4 problems, declare your answers, and then unpause when you're ready. Okay, so I decided I was going to put this data. We didn't really have room for it on the table, so I just declared it. If the tree has been growing by 4 feet per year, and it appears as if that's a trend where it's every year it continues to grow at 4 feet, then we could work our way backwards and say year 2, it must have been 13 feet. 1 year after it was planted, it was 9 feet. And then year 0, which is the year that the sapling was planted in the forest, it was 5 feet tall, okay? So with that being the case, our rule is Y equals 4x plus 5, because 4 that's being multiplied times the x is how much it's growing per year. And in year 0, it was 5 feet tall. So the tree was planted and it was 5 feet tall. And every year thereafter, it grows 4 feet. So if x was equal to 5, then this would be 4 times 5. That would have meant it grew 20 feet in 5 years. So if it started at 5 feet tall, it's now 25 feet tall, okay? So it's really important for you to understand we're using this rule, these equations, model the real world situation. And every single one of the parts of these rules has a very specific meaning in the context of this problem. The 5 represents where it started when it was first planted. 4 tells you how much it grows per year, and that's a rate. That's a growth rate. It's multiplied times the number of years since it's been planted. So in this case, the X represents the number of years after planting. This would be your X right here. And then the Y is going to be how tall the tree is after X number of years. So Y is the dependent variable, and Y represents the height of the tree. Okay? So now that we've got all that clear, we can use this rule to now solve any problems that we have regarding the height of the tree or the number of years after it's been planted. John wants to know how tall the tree will be in 20 years. So X represents the number of years, so we'll replace the X with the 20. Then we'll go through and simplify this expression. 4 times 20 is 80, and 80 plus 5 is 85. So that means that the tree should be 85 feet tall after 20 years. Now, one thing to be aware of is we are assuming it's always going to grow by the same rate. You could have some years where there's more rain than others. You could have some years where it's colder than others, and different factors could influence the growth of the tree. But we're in the business of making predictions and approximating height. And so we're going to go with this, and maybe plus or minus 2 or 3 feet. It's probably going to be pretty accurate. All right, the tallest tree in the world is 367 feet. So how long would it take John's favorite tree to reach that height, assuming it's going to continue growing at the same rate? This situation requires us to replace the Y with 367 feet, because that's the total height of this tree. And so we have to use algebraic reasoning now. We would remove balanced sets by subtracting the 5 from each side. The reason why we want to take away this 5 is because we're eventually trying to figure out what X is equal to. So we've got to get the X alone. So let's get the X term by itself first by taking away 5 from the right side. And whatever you do to the right side, you have to do to the left side of the equation. You got to remove the same amount from each side to keep everything balanced. So that means that 4x is equal to 362, and now we'll divide each side by 4 because we need to know what do you multiply times 4 to give you 362. Well, to figure that out, we'll take 362 and divide by 4. 362, and you divide that by 4, and you get 90.5. So in 90.5 years, that is when we would expect this tree to be 367 feet tall. Okay. So, did you use algebra tiles to solve the equation in part D? This question is sort of assuming that you're in the classroom and you have access to the algebra tiles, but you could have also used online resources for previous lessons to build this. Would it be easy to use the algebra tiles is probably the better question we should answer. And I would say no, it's probably not really easy to use the algebra tiles because we're talking about numbers that are pretty big. So it's nice to use the algebra tiles when we're working with small numbers because you can model the situation easily. But if it starts to become too complicated because the numbers get bigger, that's when it's time to transition to using our algebra, our equations, and our rules. So that's what we did here. Much easier to work with the rule and get the exact answer than try and model the situation using our manipulatives. At this point, we should just be good using our rules and equations. Speaking of rules and equations, here are 4 equations I would like for you to solve. We need to continue practicing this process. Remember, it's really important that you record your work, and it's really important that you check your solutions, okay? So please copy down each one of these problems, work through the process, and declare your answer. Well, don't declare your answer until after you check, because if you make a mistake, you want to go and fix it. So go ahead, I'll pause, you pause. This should take you anywhere from 5 minutes to 20-some minutes, depending on how fast you write, your proficiency, understanding how all this works. Do your best. If there are some of them that are just a little confusing and you want to wait for me to show the process, I'm okay with that. But really, you're going to learn the most by doing it, even if you make mistakes, because you learn from the corrections of your mistakes. So copy the problems down, show your work, check your work, declare your answer. All right, let's see how we did. First problem says 75c minus 300 equals 25c plus 200. Now, you've got your variable on both sides of the equation, and you've got to collect them on one side. So I always collect them on the side where the number that's attached to the variable is the greatest. 75 is greater than 25, so I will collect my variables on the left side, which means I'll have to take away 25 c's from each side. That's what's going to form this zero pair. Do I have my marker here? Do I have my marker? Which one? This is what's going to form my zero pair right there. Now, I decided to do all this in one step. Since I know I'm going to collect my variable on the left side, that means I'm going to move the constant to the right side. So I've got to clear out this negative 300 there by adding 300. So I've removed balance sets and added balance sets. And what I get as a result is the equation 50c, right? 75 minus 25 is 50. And 200 plus 300 is 500. So 50c is equal to 500. Now, what number do you multiply times 50 to give you 500? That would be 10, correct? Because we'll take and divide both sides by 50, and 500 divided by 50 is equal to 10. So if this is correct, 75 times 10 is 750. 25 times 10 is 250. 750 minus 300 is 450. And 250 plus 200 is 450. So our check worked out. The left expression is equivalent to the right expression when our variable is equal to C, which means the solution for C is 10. Now for B, copy the problem down, combine like terms, and what do we notice here? We notice a situation where 15y minus 4 is supposed to be equal to 15y plus 6. A quantity minus 4 can't be equal to the same quantity plus 6. Now, if we took the time to take away the 15y's from each side, you'd see that negative 4 equaling 6 is not a true statement. So that means there's no solution there, and we can't really check that because nothing we check should work. For problem C, copy the problem down, and this is one where I think it's just good to do a little mental math. What number do you multiply times 1/2 to give you 6 for an answer? Half of 12 is 6, correct? But that's negative 1/2. So we're going to multiply a negative times a negative to give us a positive 6 for an answer, which means that x has to be equal to negative 12. Now, if you did want to show the work on each side, what would I need to multiply times negative 1/2 to make this equal to positive 1? So we could write this as 1x. That would be negative 2. Multiply the number times its reciprocal, and since it's a negative, this also has to be a negative, because a negative times a negative will give you that positive 1. So then you multiply this side times negative 12, or times negative 2, to give you the negative 12. So a couple different ways of thinking about it. One of them, you're showing a little bit of work and using inverse operations, if you will. Inverse operations meaning the opposite, like adding is the opposite of subtracting, and multiplying is the opposite of division. And yes, we did multiply something that was already being multiplied, but it was a fraction. So in this case, we're thinking of like reciprocals are like opposites of each other. Okay, so let's check to make sure that works. And half of 12 is 6, so negative 1/2 times negative 12 will give you the positive 6 that we need to give us our correct answer. And for D, we can't combine like terms, so I'm going to begin doing the same thing as before. Negative 2 is a greater number than negative 3. If you did KFC, you would see that this is 0.8 plus a negative 2t, so that negative sign is a part of the 2, and the same thing applies here. This could be 1 plus a negative 3t. but I'll call this 1 minus 3t and just assume that that negative sign is a part of the 3. So negative 2 is greater than negative 3. So if I add 3t's to each side, that is going to zero this guy out. But you have to also add it to the left side, so it's going to become 1t. I decided in the same exact step, just like I did over here, to take away this 8/10. So I have to take away 8/10 from the right side as well. This forms a 0, and so you get negative 2 plus 3 gives you that 1t on the left-hand side, and 1 minus 8/10 is 2/10. So our solution here for t is 2/10. Now let's go ahead and check that. Let's plug those numbers in. If you take 8/10 minus 2 times 2/10, that would be minus 4/10. You get 4/10 for an answer. If you take 1 minus 3 times 2/10, 3 times 2/10 is 6/10. 1 minus 6/10 is also 4/10. So that ensures that we've got the correct answer. T is equal to 2/10. Okay. I hope this is getting easier. You know, the problems, the days of us solving really simple equations, those days are over, unless, of course, it's a simple equation that is created whenever we're doing problem solving. Okay. So you just got to be ready for more complex examples. And so practice makes perfect. All right, last problem. We get to revisit Mr. Wallace's tip table. Okay, so after much consideration, Mr. Wallace decided to use the tip table below to help him estimate what a 15% tip would be for various dinner costs. Okay, so this is not exactly the same as our tip table. We use some friendlier numbers, but this is certainly a good one. I think ours started at $10 and went to 100, just like Mr. Wallace's here, but he includes, I think, 35 and 45, where we just counted by tens. So it's important to note that the multiplier that we use when we're factoring in a 15% tip would be 1500s, because 15% literally means 1500s. So this becomes our multiplier. We take 10 times 1500s, it's $1.50. You take 20 times 1500s, it's $3, and so on and so forth. So your task is to, just like you did with John's giant redwood in a couple pages ago, is to find the rule that fits in with this particular situation. We're going to make y the amount of the tip, and we're going to make x the dinner cost, okay? So go ahead and find that rule. And then move on to part B. After dinner, Mr. Wallace was so distracted he forgot to write down the cost of the meal. All that he can remember is that he left a $9 tip. So use this rule to figure out if y is equal to 9, what would x be? What would the cost of the dinner be? And then once you figure that out, go ahead and declare what was the total cost of the entire dinner with tip included. Okay? Spend about 5-10 minutes working through these 3 problems, declare your answers, and then unpause when you're ready to check. Okay, so what do you multiply times x to give you y for an answer? That would be your multiplier 1500ths. So that's our rule. Y, the amount of the tip, is going to be equal to 0.15 times x. And when we use that, we would plug in for part B. If we're going to use that to find the amount of the dinner, that would be finding the value of x when y is equal to 9. That's going to involve us using algebraic reasoning and dividing each side by 1500ths. And take your calculator and say $9 divided by 1500ths will give you 60. So that means that the amount of the tip, I'm sorry, no, the amount of the dinner must have cost $60. Okay, so if the dinner was 60 and the tip was $9, and the total cost of the dinner was $69. Okay, so go ahead and head over to the homework. Do the best that you can. Make sure you show your work Make sure that you are, especially when we're working through word problems, that you are using the 5D process that we practiced so much in 7th grade. For those of you that are brand new to the school, we will kind of revisit the 5D process. It's just problem solving. Um, it would be nice if you would have learned it in 7th grade with us, but I'm sure you used a process that hopefully works for you. And it's probably essentially the same thing as the 5D process. It's not like some earth-shattering new type of math. It's just 5Ds stand for the different parts that you do when you solve a problem, which everybody does those parts anyway, whether they call it 5D process or not. So, forgot where I went off on this tangent, but at any rate, show your work and do the best you can and be prepared to make your corrections if you need to. All right, take care. Bye-bye.
Hey, feeling good, like I should. When